So hi everyone. Today I'll be talking about using React with Inertia.js and how you can speed up front-end development by using it. So I'll be going over a general summary of what Inertia.js is, perks of using it, and new features that were introduced in version 2.0, which Inertia.js version 2.0 came out of beta, I think in January or February of this year, so still somewhat new. But first, I'm sure you all want to know, who am I? If not, you're going to find out anyways. So like was just said, my name is Leah Thompson. I'm a Florida native who now lives in Colorado. I enjoy hiking and just being near the mountains in general. I also enjoy reading, though I mainly read fiction and anything and everything that are not technical books. I like reading as an escape, so I don't really read technical books. Before getting into tech, I worked as a high school geometry teacher for about 2 years before I quit so I could focus on software engineering full time. At this point, I've worked as a software engineer for for exactly 2.5 years this month. And currently, I work as a front end engineer at Laravel on the DevRel and marketing team. So there, I work on different landing pages for products that are coming out, any tools for the marketing and DevRel team, as well as doing like general DevRel stuff like speaking at conferences and giving talks like the one today. But today, instead of teaching you all geometry, which I'm sure you're all devastated that I'm not teaching you about math, instead I'll be teaching you about using Inertia.js, using React with Inertia.js, and how you can speed up front-end development by doing it. But before even really getting into what Inertia is, I kind of want to tell a story to like set the scene of why you would want to use Inertia and why it's useful in general. Okay. So when starting with web development, I started getting into web development in the beginning of 2022. So when getting started with web development, I started out using the MERN stack, which is what this is a lovely picture representing. So the MERN stack is MongoDB, Express.js, React.js, and Node.js. So with MERN stack, you have two separate applications, right? You have a separate front end, and then you have your back end. So that's what I was used to when getting started with full stack development with JavaScript, because MERN stack is also a full JavaScript stack, which I feel like is pretty popular for other people who are getting into full stack using JavaScript. It might be a little different now that Next.js is as popular as it is, but I think a lot of people here can also relate, which kind of leads us into the topic of monolith versus separate front and back ends. So kind of what the difference is and why, like what might make it easier to have a monolith or like the perks of it. So compared to a monolith, having two separate applications, so having your separate front and back end can make it harder to trace down errors if anything goes wrong with your application. You're having to go between the two separate applications, right? So you're having to go between your front and back end, trying to trace the error back, trying to debug and see if it fixes it, and it can just take more time and be more complex. So that also can make it harder to maintain the application since you have the two separate ones, and also you end up writing more code in general, especially if you're having to create containers for them, right? Because then you have two separate Docker containers instead of them just living in one. So you're just adding to the complexity. Of course, it is also a preference. Like some people just don't like monoliths, and that's okay if you want to just have separate applications. But for the purpose of this talk and with using Inertia.js, I like writing monoliths. So just explaining for me the reasons, like the perks of writing a monolith, right? So kind of like what I talked about with monoliths, we replaced our monolith with microservices so that every outage could be more like a murder mystery. So it's talking about like what I just said in the other slide, where if you have a monolith or where if you have the two separate applications, it can be harder to trace the errors. Here, if you were using microservices instead of the monolith, you have even more services to manage. So then every outage is a murder mystery because you have to hunt down where the error is and try to debug it. So back into what I was talking about though, with me getting started with MergeStack, right? You might be asking like, what was the purpose of bringing that up? So I started with MergeStack when learning web development. So for the capstone project for the program I did to learn web development, I decided to build a multiplayer math quiz app. So I spent about 200 something hours building this math quiz app. For it, I decided to delve a little bit outside of the MERN stack, and I built this using React, Python, Flask, Socket.io, and MongoDB. So still similar to the MERN stack, still had a separate front and back end for this. And then I'm going to kind of talk through the app, but while I am, I'm going to let me play this. Yeah, play the demo. So this video is like a demo of the app. So the app allows you to quiz yourself on a math operator of your choice. So addition, subtraction, multiplication, or division. Each time you started a quiz, it would generate 10 random questions of whatever type you picked. So addition, subtraction, whichever one. And then it would also generate a room code, which is what you see on the left-hand side with the lobby code there. So it would generate a room code that you could then share with your friends so that they could join the same like quiz room as you and compete against you on the same math quiz. But, and like you can see in here, I'm like showing that you answer the questions, and at the end it would show you like who won or like who got the most right. But if you remember, we're talking about inertia today. So you might be asking, like, how does this tie into my math quiz app? Well, it ties into the story because as I was learning Laravel, which I started learning last year, which Laravel is a backend framework, a full stack framework for PHP, basically. And when I started learning Laravel, I decided to rebuild this application using React, InertiaJS, Laravel, and Tailwind. And by doing this, by recreating this application now using Inertia.js, I realized how much it simplified things, like how I was able to build the application faster and how it just took away a lot of the complexity of it. And that is why that kind of led me into talking about Inertia.js and appreciating it so much, which is why I'm talking about Inertia.js today. So now focusing on Inertia.js. It leads us into this big question of what even is Inertia.js? Because I feel like a lot of JavaScript developers do not know what inertia is. It's obviously harder to like ask questions of the audience when you are virtual and you can't like physically see people. But if you have never heard of Inertia.js or used Inertia.js before, please type in the chat, like me, or just type something in the chat that you've never heard of it. I'll go back and read it after this talk. But I just want an idea of who's never heard of Inertia.js before. Because my assumption would be it's a good amount of people. Oop, hold on. I exited out. Okay. Sorry, technical difficulty. Okay, so let's get into what inertia is. So InertiaJS is a library that bridges together your front and back end. So you can think of it as like the bridge between the front and back end. You can think of it as the glue. So it's the thing that glues them together. It does this by allowing you to write a monolith. So it takes away the need for a separate API layer, which also is why I was talking about a monolith versus separate back end front end. So Inertia allows you to write the monolith. I also think it's worth mentioning that Inertia.js is fine-tuned for Laravel. So if you look up resources for Inertia.js, a lot of them are going to be using Laravel on the backend, but that does not mean that you can't use Inertia.js with other backend frameworks as well, because there are community adapters. So here's a list of some of the other community adapters for Inertia.js. So there's a community adapter for Ruby on Rails, Django, Flask, Golang, and more. I think Elixir is also one of them. You can find a full list of the other community adapters under the Inertia.js docs on that website. These community adapters are like it sounds. They were created by the community for the specific backend frameworks. So they are also maintained by the community versus the official Inertia.js package is maintained by Laravel and it's fine-tuned for Laravel. The main idea behind Inertia.js is that you can build your backend using whatever backend framework of your choice. So using Laravel, Ruby on Rails, Elixir, and leverage your usual controllers, auth, whatever goodies you enjoy about that framework, but then use a JavaScript framework on the front end, which we're here at React Day. So we're going to be talking about React, but you could also use Svelte and Vue as well. And now, I've kind of talked about what it is. So you might be thinking like, how can this speed up front end development though? Well, the big thing of it is or a big part of that is instead of having to make separate Axios or fetch requests to get any data from your backend, right? Instead of doing that, you can just access the data as a prop on the page component. And I will show like an example of how you can do that. But you're basically on the backend returning your component and sending over whatever data from the backend that you want that you can then access as a prop on that component on the front end. So this slide and the next slide are code snippets. These are from the Inertia doc, so from the website. And these snippets will show kind of the code to access this both on the front end and the back end. So if you're looking at this right now and you're like, what the heck is this? This is the code for the backend side. So this is an example in a Laravel controller. Since I mainly use Laravel, I will be focusing on Laravel for the backend examples. But there's not that many. It's mainly just this. Most examples are React. So this is a Laravel controller. So on the back end, whatever framework of your choice here, this is just showing how you would return the components, right? So here we have a controller, which is user controller. Inside of this, we have a method, which is show, and we are passing it a user object. Then inside of this here, we are returning that. So we have return inertia render. Inside of our render function, we have two parameters. So the first is a string that is user/show. So this represents the name of our component that we want to render or we want to return from this method. The second parameter is an array, and this array will have all the data that we want to send to that component. So the data from the backend that we want to send to that component to then access as a prop on the component. In here, we're sending a property called user, and the value for that is our user object that we're getting passed into our show method here. And notice for the name of the component, we don't need the file extension, so we don't need .tsx or anything like that, but this is just the string that represents the name of that component. So this is the backend side. On the flip side, here is the front end side. So we're back in React land, which everyone here should be familiar with. Notice the name for this is different. So this is welcome. This again is from the docs, but we would just pretend for the sake of this that it's the same name as what we are returning here. So really we want this to be user/show, right? Whatever we're returning here, whatever string we have is going to be the name, the same as the name of that component that we're sending the data to. So just pretend it's user/show here. But notice that we can access that user property now as a prop for this component. So we see it right there. We have user. So inside of my return function, we have our layout. And inside of the layout, we have a p tag, so a paragraph element. And we're able to just say hello, and then in curly braces, user.name. And we're just able to instantly take the user object that we sent on the backend. Remember, we sent user, which had the value of the user object from our backend. We're able to just take that and instantly use it in our application. We didn't have to do any external fetch or Axios request or anything like that. We just can instantly access that property and use anything that is on it, which can just make things very simple. Like if you looked at this example and the one before it, is very short. We had very few lines of code to just be able to use that property, which removes the need for, you might have guessed it, the fetch and Axios request, which after Maya's talk, I might be reacting wrong in this example, just ignore it. For now, I will fix that, but this is just kind of an example of boilerplate of what we would have or what you would expect for an Axios request, right? Or a fetch request to get that same kind of data that we were just passing in as a prop. So here we have our Axios request wrapped in a use effect hook. We have an empty dependency array for it. Then we're doing our Axios call. So we have axios.get. Inside of this, we have our URL for our API endpoint to get data for a specific user by passing in the user ID. Then you have the response, and you are setting some state, some React state to that response, or to be that response.data. And then maybe you're setting some loading state. Then you would have a catch block where you have your error and you console error it. And then you maybe set like loading state to something else. So this is just like an example of what one fetch or Axios request would be, right? Which maybe it's just a few lines of code. It doesn't look like a lot. But if you're doing this multiple times, it can really add up and just take a ton of, or it can just take a lot more code, right? A lot more boilerplate. So comparing this to the other slides, this is just a lot cleaner and just removes a lot of boilerplate. But this is kind of just scratching the surface of Inertia. We've just kind of talked about the main things of it. So let's talk about other perks of using Inertia. One big perk of using Inertia and something that I personally enjoy, I think also something that made, it's like one of the reasons why it was easier for me to remake the math quiz app that I talked about before using Inertia, is that Inertia just makes dealing with forms just easier, which forms are an extremely important part of any application. I'm sure everyone can agree with that. As developers, I'm sure everyone here has worked with forms in their applications. And Inertia makes it really easy to work with them. It is possible to make classic HTML form submissions using Inertia, but it's not really recommended since they can cause full page reloads. So instead, it's better to intercept the form submission and then make the request using Inertia. So to help with that, Inertia includes a form helper, which is use form. So like you see here, but it's not, instead of all caps, which I just did for the sake of matching the rest of the slide, it's lowercase except for the F. So use form reduces the amount of boilerplate code you would have to write for your forms. It does this by simplifying handling form state and submissions in JavaScript by providing reactive form data, automatic error handling, and status tracking, like processing what's successful and recently successful. It works seamlessly with server-side validation responses, binding errors directly to form fields, which makes form handling in Inertia apps feel more like a traditional single-page application while still leveraging server-side controllers. Okay, that was a lot of talk about the form helper, which I might have went through kind of fast, but let's kind of break it down. So this is an example, again in React, of how you would implement the form helper, right? So up here, you can see where we're using the use form helper. We have const, we have our destructured object that has properties data, set data, post, processing, and errors that are all coming from use form. So from that form helper. Here, data is our form state. So it's our dynamic form state. Set data is what we're going to use to update that form state as the user is typing in the new values in the input fields. Post is what submits it. So post is what we're using to make the post request. And errors holds our validation messages, which we'll talk a little bit more about later too. And then we have our submit function below that. So in the submit function, we have e.prevent default. So we're just preventing the form from submitting on default. And then we are making our post request to the login route or our login endpoint. And for the post request, it handles the rest. So doing the post with Inertia, it will automatically handle CSRF, redirects, even flashing validation errors. And then inside my return statement down here, or return function, in our form, you can see for on submit, we're setting it equal to that submit function. For the value, we are setting it equal to data.email. So data. All of the properties which we initialized here. So whenever we do use form of email, password, and remember, we are setting those values for our form data. So they're stored under the data variable here. So we are initializing email to be an empty string, password to be an empty string, and remember to be false, which is a Boolean. And then we can access those down here for the values by setting the value equal to data.email. And then for the onChange functions, we are utilizing that set data function from Inertia.js to update those values. For error handling, so where you see we are getting errors here from the form handler, the error handling is baked in. So the form validation is done on the back end, which means we don't have to validate any of that data on the front end first. We would just let the user type in the data, send the form submission. It would go to the back end, which I'm going to focus on Laravel. So it would send the request to your Laravel controller. The controller would then do the data validation. If there's an error, it would send it back to the front end, and Inertia.js would just inject them into the component. So you can just access it in this errors variable here. So there's no need for any special Axios or weird Axios error handlers or weird catch blocks. You can just instantly access those errors, which is really nice again. And again, removes more boilerplate code. Besides the form helper, some other features that Inertia offers is Inertia enables a method to make shared data available with every request and maintains server-side rendering to offer cohesion with SEO-friendly pages, but while offering the same speed as with SPAs. Inertia, I think I talked about a little bit with the forms, but also with like general link clicks as well as the form submission. Inertia intercepts those clicks. So it intercepts link clicks and form submissions so that only the component updates and not the entire page reloads, which makes it feel like a SPA without the boilerplate of an SPA. There's also built-in support for showing loading bars on page transitions, and you get history navigation, scroll restoration, and more out of the box with Inertia. Okay, and then we've already talked about general stuff with Inertia. Let's talk about the two features, which I'll kind of try to wrap up because I might be going over my timer reset when my slides crash, so I apologize about that. So for V2, which, like I said, came out of beta in January or February of this year, the core library was completely rewritten to architecturally support asynchronous requests. So now it supports prefetching, deferred props, infinite scrolling, lazy loading, and more. With the asynchronous requests, Inertia now is able to allow multiple requests to happen simultaneously without blocking each other, which means you can perform background data updates or form submissions without interrupting the user's experience. And an example of like how this is used in Inertia now, the reload method is now async by default so that it provides a more fluid user experience. Inertia.js version 2 also introduces polling, so you can keep your UI in sync with, introduces polling, which allows you to keep your UI in sync with server state for real-time applications. And it does this by simplifying polling and introducing a use poll helper. So kind of like the form helper, now there is a use poll helper, and you can set up automatic or manual polling to refresh data at specified intervals, ensuring your application stays up to date without requiring user input, which is ideal for applications that need to frequently update data, such as live statistics, chat applications, anything like that. And then there's also other things like infinite scrolling, lazy loading, deferred props, and more, but I won't go into those. Instead, I will wrap up. And thank you all for listening to my talk today. Maybe some of you've already used Inertia.js. If so, I'd love to hear how you used it. And if not, and you do use it and go out and build something with it, please let me know what you think.
Thank you so much for your amazing talk. I think it was new for many people, as before we didn't have any Inertia talk. We will go through the questions because we do have a few of them. A person is asking, how does it handle the request in the background? I mean, does it send a request and receive data too?
I'm a little confused what the question means.
Yes, I think it was referring to something that you were showing, but we passed that thing. So maybe the person who asked that question can go back, refine it a little bit, and then we will go back and ask it again.
Okay.
Let's go to another one. What's the hardest part about learning Inertia.js, and how can I avoid common pitfalls?
That's a good question. I feel like Inertia.js isn't that hard to learn. I don't know if it's because of me starting with like building with like Mern and stuff like that first and then going to Inertia though. I feel like it wasn't that hard to pick up. I would say maybe getting used to like writing a monolith because you could use Inertia, right, and still just return JSON from your backend and then make the separate Axios and fetch requests on the front end. Like it doesn't force you to use the pattern like I talked about, where it said you're returning
Mhm.
Inertia render and rendering the components on the backend. So I think maybe like the hardest part, not really about learning it, but about using it, is getting into that technique or like used to that pattern of writing your applications. And then maybe knowing when to use the other features of Inertia, because Inertia offers server-side rendering. Like it uses client-side rendering by default, but you can do server-side rendering. So I would say just knowing when to use the other features of Inertia and not getting overwhelmed by everything Inertia
Mhm.
offers when you're trying to first learn it.
Awesome. Another person is asking, what's the biggest aha moment you've had while using Inertia.js?
I would say just whenever I was rewriting the math quiz app and whenever I realized like, oh, I'm not having to like return all the JSON on the back end and then on the front end, like get the like do the separate request to get the JSON and then like reshape the data how I need it and then like make sure I have it right and update the React state and do all of that. Instead, it's just like, oh, I just send the prop over and it's just done. Like I just have the data, it's fine. Dealing with that as well as like the forms, once I saw how much it simplified the forms and then automatically like everything on the back end was just in sync with that
Mhm.
because it just sends it over. That felt like an aha and like a magic moment, you know, when you're comparing it to Mern and stuff like that. So I'd say that was like those two things were my biggest like aha moments, which is also why I focus on them a lot in my talk.
I see. Let's go to our last question. Although
Mhm.
we have more, I don't feel that we have a lot of time, unfortunately.
Mhm.
So, another person is asking, if I'm coming from pure React SPA background, what's the biggest mindset shift I need?
I feel like I kind of answered that with my other answer. I feel like it's just like getting used to writing in like a monolith
Mhm.
and getting used to that pattern is the biggest mindset shift. I don't think other than that, like there's a huge mindset shift. I think also if you're using like React and you've been using like Remix and stuff like that, like I've heard like the form capabilities you get with Remix is like similar to a lot of the Inertia.js form stuff and stuff like that. So I feel like a lot of it is similar. I think the biggest mindset shift is just getting used to returning your React views on the back end and stuff like that versus having just two completely separate applications.
Thank you very much. And that was our last question. I know that we have more, but maybe the folks, instead of asking us here, maybe they could check with Leah on social media.
Mhm.
Maybe that's a solution. Thank you very much for being with us, and thank you for the amazing talk, Leah.
Yeah, thank you so much for having me here. Anyone, if you have more questions, feel free to find me on LinkedIn or Twitter and ask. You can find me under Leah T Codes.
Thank you. Have an amazing day ahead.
Thank you, you too. Bye.